Hi folks. The next section of our textbook involves solving multi-step inequalities. So here we're going to combine what we learned in the last two lessons, solving inequalities using addition and subtraction and solving inequalities using multiplication and division. And we're just going to do things exactly the same way we did with solving equations. We're going to do things in reverse PEMDAS order. So the general procedure we're going to use, there's no new vocabulary we're learning, but the general procedure is we're going to simplify any expressions that we have using PEMDAS. So going in forward PEMDAS order to simplify expressions. And then we'll solve the inequality using reverse PEMDAS order. If necessary, if x appears more than once on the same side of the equation, then we need to collect all variable terms on one side of the equation and all constant terms on the other side of the equation so that we can isolate the variable. So let's look at a simpler example of a multi-step inequality. Here we have y that's being divided by -6 and also being added by 7. Now, when we have a division problem and an addition problem involving our y, remember we want to go in reverse PEMDAS order. So we want to take care of any addition subtraction first, and then we'll take care of multiplication division, then exponents, then parentheses. So here I want to take care of any addition subtraction first. So this adding 7, I want to remove this 7 by subtracting it away, because subtraction is the opposite of addition. And when I subtract that away, I'm left with y divided by -6 is less than 2. Now, how do I solve for y in this example? Well, to get y as a positive number, there are two approaches to this. So I'm going to go ahead and do it both ways. Let's do the addition subtraction way. So another way to write y divided by -6 is negative y divided by 6 is less than 2. So if I add y over 6 to both sides of the equation, I'm left with 0 on the left-hand side. And on the right-hand side, I have 2 plus y over 6. If I subtract 2 from both sides of the equation now, I have -2 on the left side. The 2's cancel out here because 2 minus 2 is 0. And I have y over 6 on this side of the equation. Now I can focus on getting y all by itself by multiplying both sides times 6. And I get that y is greater than, let's see, -2 times 6 is -12. So -12 is less than y. Now, some of you may be saying, hey, when we had y divided by -6 is less than 2, why don't we just multiply both sides by -6? And you can solve the problem this way. -6 divided by -6 is 1, so we're just left with y on the left side of the equation. On the right side of the equation, 2 times -6 is -12. What we need to watch, though, when you multiply or divide both sides of the equation by a negative number, you need to reverse the orientation of the inequality sign. So this was a less than sign, it is now a greater than sign. So if you compare the two methods that we used to solve this equation, we ended up with the same answer, although it's written in a different order. Here we have -12 is less than y. -12 is on the small side, because that's the point of the less than symbol, and y is on the greater side. And here y is on the greater side and the -12 is on the smaller side, the closed side of the inequality symbol. So both of these mean the same thing. This is the correct solution, just obtained two different ways. But please be aware of that hiccup here that happens with the sign. When you multiply or divide both sides of an inequality by a negative number, you must reverse the orientation of the sign. Let's do another example here with question B. 6x minus 5 is less than 2x plus 11. There are no expressions here that I need to simplify. but I do have variable terms that need to be collected on the same side of the equation. So I don't want to have an x here and an x here. I want to have all my x's on the same side of the equation. And because we've learned that it's a pain in the butt to deal with negative coefficients with x, because then we're left either remembering to reverse the sign or to add the variable to both sides of the equation, I'm going to make sure that I don't have a negative number here. I'm going to subtract 2x from both sides of the equation so that when I do that, the 2x minus 2x disappears on the right side of the equation, and on the left side, I'm left with 4x. If I had done my subtraction the other way, if I had subtracted 6x from both sides of the equation, I would have had a negative value, negative 4x on the right side. And I don't want to deal with the negative number. So 4x minus 5 is less than 11. So again, I'm trying to isolate x. I'm trying to get x all by itself. But I've achieved my first goal, which was getting all of my x's into one place. I will now add 5 to both sides of the equation, and I'm left with 4x on the left side is less than 16. So how do I get x all by myself? All by itself. X is being multiplied by the number 4, so to get rid of the 4, I have to divide the 4 away. And my final answer is x is less than 4. Let's look at another example. Oh, actually, I'm sorry. Before we move on, whenever you have more than one x in an inequality, there is a chance for some funny solutions that don't actually work out. So it's important to test our answers to make sure that it is a true solution. So let's plug this 4 back into our original equation. 6 times 4 minus 5 is less than 2 times 4 plus 11. Now, 4 is not actually a solution to this inequality, but it's right on the border. So, so we should see a value that is that doesn't work as a solution, but is right on the borderline of what a solution is. So if I use order of operations here, 24 minus 5 is 19. And on the right side of the equation, 2 times 4 is 8, plus 11 is 19. So while this is not a true statement, I was testing a number that I wasn't expecting to give me a true statement, but it is right here on the cusp. I'm basically testing the equal number to make sure it works, because when the same variable appears on both sides of the equation, funny things can happen with solutions. Let's look at another example. For question C here, this inequality does have an expression that can be simplified. Right here, I have a number multiplying an addition problem inside parentheses, and I can use the distributive property to simplify this. So 4 times 2b is 8b, and 4 times 3 is 12. So I've simplified the right side of the inequality, and on the left side, I still just have 8b minus 3. So now I'm going to subtract 8b from both sides of the equation. And when I do that, I get the statement, negative 3 is greater than 12. This is a false statement. This can never be true. And because of that, whenever you get a false statement like that, that means that there are no solutions to this inequality. No solutions. So we don't even have anything funny, anything to test to make sure that there isn't anything funny going on. We got that result right away. Let's look at another example. 2 times the quantity 5w minus 1.2 is less than or equal to 7 plus 10w. 2 is outside the parentheses here. We want to multiply inside the parentheses, everything inside the parentheses. So 2 times 5w is 10w, and 2 times negative 1.2 is negative 2.4. And that should be less than or equal to 7 plus 10w. Once again, I want to combine all of my variables on the same side of the equation. So let's subtract 10w here and subtract 10w here. And I end up canceling out my w's on both sides of the equation. And I get the expression, or the inequality, negative 2.4 is less than or equal to 7. Less than or equal to 7. This is a true statement. It's always true. So this indicates that the solution set is all real numbers. All real numbers. If you end up with a statement that is true without any variable in it, that indicates that the solution set is all real numbers. Let's look at a real-world example of an inequality where we might need to solve for a missing variable. So, I've played 4 games of trivia. You can see my scores here. And I need to score an average of at least 90 points to advance to the next round. So what do I need to score in game 5 to allow me to advance? Well, first of all, we need to make sure we remember how to calculate averages. Averages, you sum all the values, and then you divide by the number of values that you added together. So in this example, I'm going to have 5 scores. I'm going to have 95 plus 91 plus 77 plus 89 plus my mystery score, and I'm going to have to divide by 5 scores. And when I do that, I want my average to be at least, so greater than or equal to 90. So this is the inequality that I'm trying to solve. Now, normally, I've always said go in reverse PEMDAS order. So it looks like we want to take care of addition and subtraction first. That's not totally the case here because all of these numbers are on top of my fraction. They're all in the numerator. So it's like these are in parentheses. So I'm actually going to want to take care of the division problem first before I take care of these. However, the very first step is always to simplify if we can. And I have 4 like terms here that can be added together. So 95 plus 91 plus 77 plus 89, that all adds up to 352. 352 plus the x divided by 5 is greater than or equal to 90. And now I can work on getting rid of the 5. So I'm going to multiply both sides of the equation by 5. Those cancel out because 5 divided by 5 is 1, and multiplying by 1 doesn't do anything. I have 352 plus x is greater than or equal to 450. Now, to get x all by itself, x is being added to the 352, so I want to subtract the 352 away. And I am left with x is greater than or equal to 98. So long as I score a 98 or higher, I do get to advance to the next round. I hope this helps.